Hi, everyone. Welcome to this lecture series on steel structures. In this lecture series, we will focus our attention on steel buildings, their design and construction. We will discuss different steel forms, various components making up steel structures, steel connections, composite structures involving steel and concrete, plate girders, and variety of steel connections. In the first part, we will try to understand the behavior of steel buildings, types of steel buildings using AISC LRFD code of practice. So let's start off from steel structures. Steel structures refer to construction that primarily use steel as the main material for support framing and other essential components. Steel is a popular choice for structural application due to its strength, durability, versatility, and cost effectiveness. Steel structures can be found in various forms and applications, ranging from small scale residential buildings to large scale industrial facilities. There can be different types of steel structures, such as residential buildings, commercial buildings, industrial buildings, bridges, high rise buildings, stadiums and arenas, agriculture buildings, and so on and so forth. Steel, often used in residential construction for framing beams and columns. It provides a high strength to weight ratio and allows for open and flexible floor plans. Similarly, many commercial structures such as office buildings and shopping malls use steel for their framework. Steel strength allows for large open spaces without the need for numerous support columns. Factories, warehouses, and other industrial facilities commonly use steel structures due to their ability to support heavy loads and withstand harsh environmental conditions. Steel is also commonly used in bridge construction due to its strength and durability. Steel bridges span long distances and support heavy loads. Large supporting and entertainment venues often use steel structure to create expansive and open spaces for seating and different activities. Therefore, stadiums and arenas are built from steel structures. Different warehouses or agriculture buildings are also built from steel. So, this is just a brief overview of types of steel structures. Now, let us briefly discuss advantages of steel structures. Steel has a high strength to weight ratio, making it suitable for structures that need to support heavy loads. It is also durable and resistant to many environmental factors. The second advantage of steel is its versatility. Steel can be shaped and fabricated into various forms, allowing for a wide range of architectural design and applications. Another advantage of steel is its speed of construction compared to concrete structures. Steel structures can be erected quickly, reducing construction time and associated costs. The fourth advantage of steel is its cost effectiveness. While the initial cost of steel may be higher than some other materials, its durability and low maintenance cost make it cost effective in the long run. Another advantage of steel is its recyclability. Steel is highly recyclable, making it an environmentally friendly choice. So these were few of the advantages of steel structures. Now let us discuss about different components of steel structures. In the case of steel structures, we can have columns and beams, we can have trusses, bracing systems, foundations, connections, flooring systems, and so on and so forth. In this course, we will discuss the design of plate girders, design of composite construction, design of composite beams and flooring system, and design of connections. Now let us discuss codes of practices. Steel, being widely used in the developing world, can be designed by using different codes of practices. The most common codes of practices are American AISC and the European Code of Practice, which is called Eurocode. In this course, we will mainly focus on AISC LRFD Code of Practice. AISC LRFD is a widely used design method and specification for the design of steel structures. The LRFD method incorporates load and resistance factors to ensure a level of safety and reliability in the structure design. Now, let us discuss distinct forms of steel structures. By forms, we mean different types of steel structures. Like we can have residential forms, commercial forms, industrial forms, long span forms such as stadium and arenas, and agriculture forms or warehouses. Let us discuss now distinct forms of steel structures. Steel structures come in various forms and configurations, each designed to meet specific architectural, functional, and structural requirements, such as steel structure can have a frame structure, either braced or portal frame. A steel structure can be made up of truss structures. It can have arch structures, cable structures, a space frame structures, or an industrial structure involving braces and trusses. So a question might arise that what are those parameters which makes one type of structure form different from another type? So we can come up with four important parameters which will distinguish one form from another. The first one is the functional framing. So as we said, the functional frame can be either a skeletal frame, a portal frame, a truss frame, an arch frame, a cable frame structure, or an industrial frame structure. In the frame structure, it is important to appreciate the route or the sequence through which loads are transmitted from point of application to the foundation. Thus, establishing a clear and efficient load path is essential for ensuring the structural integrity and stability of steel structure. Normally, the framing is subject to gravity load path and a lateral load path due to wind load and seismic loads. These loads are transferred through different structural members such as columns, beams, trusses, braces, and connections. A well defined load path is crucial for structure engineer to analyze, design, and detail the steel structure effectively. In this figure, we have got two steel buildings which transfer the lateral load and the gravity load differently to the ground. In the left figure, we have the so-called brace tube structure. The brace tube structure is made up of external braces and vertical members, which gives sufficient lateral stiffness to the structure. At the right hand side, we have the so-called outrigger brace structure. This structure is consisting of a central core, which is braced with horizontal cantilevers or outriggers coming out of the core. We can appreciate that the lateral load in the second system will be transferred differently to the ground. A structure engineer must understand what would be the best functional form to transfer the vertical and horizontal loads to the ground. So that is the first parameter which distinguishes one structure form from another. The second parameter, which distinguishes one structural form from another, is stability system. The stability system of a steel structure refers to the structural element and design consideration that ensures the overall stability and integrity of the structure, especially under various loads and environmental conditions. Stability of steel building is crucial for its safety and performance throughout its service life. Some of the key components of the stability system are as follows. We can have a lateral stability system involving bracing systems or shear wall. A lateral bracing system are essential for preventing sway and lateral movement of the structure. There can be different types of bracing systems, including diagonal bracing, concentric bracing, and eccentric bracing. Bracing can be located either internally or externally. In other words, bracing can be located within the building frame or on the exterior. The shear walls are similarly, a building might have shear walls responsible for resisting the lateral load caused by wind or earthquakes. These also provide lateral stability to structures. We can also have moment resisting frames to resist lateral loads. These frames provide resistance by allowing controlled flexing of the building structure. The bracing system, shear walls, and moment resisting frames are all examples of lateral stability systems. Similar to lateral stability systems, we can have vertical stability systems like columns and beams and foundation system, which are responsible for transferring the gravity load or any other vertical live load to the ground. Proper design and arrangement of columns, beams, and strong foundations contribute to the vertical stability of the structures. Other components in the case of stability system is a well-defined load path to ensure that loads from various sources are efficiently transferred from the point of application to the foundation and properly designed connections between the structural members. Beside this, we should also ensure out of plane stability and buckling considerations. In other words, the design should consider the stability of entire structure against out of plane movement, especially in regions susceptible to wind or seismic events. Buckling consideration is also important to ensure structural stability. So, in order to summarize, our stability system can have lateral stability system involving bracing system, shear walls, and moment resisting frames. It can have vertical stability systems involving columns, beams, and foundation systems. So far, in our parameters distinguishing one form from another, we have discussed the functional framing and stability systems. Let us now discuss construction technique of steel structures and how does it distinguish one form from another. The construction of steel building involves series of processes and techniques aimed at assembling and erecting the structural steel components efficiently and safely. Some of the key construction techniques for steel buildings are as follows. The first one is the site preparation. After that, carry out the construction of the foundation. Having foundation, then we can transport steel to the site and start with erection of steel frame. After erection of steel frame, bracing and temporary supports can then be installed. After that, floor and roof deck installation will take place. Subsequently, tertiary elements like studs, joists would be installed. After this, fireproofing, coating, mechanical and electrical systems would be installed. Finally, interior and exterior finishes would be installed and exterior cladding would be placed. So this is the normal construction sequence of steel buildings. However, there are construction techniques specific to structural forms, especially during the erection stage of steel structures. For example, we can have a top-down construction or a bottom-up construction of steel structures. These approaches refer to the sequence in which various construction activities are carried out. In the case of bottom-up construction, the building is constructed from the foundation upward. This is a traditional approach involving the same sequence we have discussed, such as preparation of site, preparation of foundation, then steel frame erection, floor and roof installation, interior and exterior finishes, then mechanical, electrical systems, and finally the cladding system wrapped around the structure. In the case of top-down construction, there are certain activities at higher level of the building initiated and carried out concurrently with the activities at lower levels. The approach of top-down construction is often used to expedite the construction process and is useful for projects with early completion or specific sequencing is critical. The top-down construction sequence typically includes, first of all, foundation, and steel frame construction. In concurrent with the foundation and steel frame, other activities like floor installation, interior finishes, and system installation may begin at higher level of the building. In the case of top-down construction, we can have the floor completion starting from the top and bottom at the same time, or we can have the floor construction starting from the top. So, for example, in this outrigger system, once we construct our foundation and the main steel frame, we start our floor construction activities from the top and progress downwards. So, instead of using the conventional way of going from bottom up, we can come from top down. So, in the case of construction technique, also, the structure engineer would have a choice of using appropriate technique, which would save time and money. The final parameter, which is important in distinguishing one form from another, is the foundation. A steel structure can have pile foundation, a pad foundation, or a raft foundation. So these are all different forms of foundation. Finally, we can say that any two steel buildings having these four parameters different simultaneously would make their forms distinct.